Hi everyone, in this video we're going to cover how to add displacement to digital models. We're going to be using Arnold for Maya, using geometry that started in Rhino. Displacement is a great way to add a finer level of texture to digital models, and it involves using grayscale imagery, either developed in Maya nodes or with image maps or in programs like Substance Painter, and using that imagery to drive small polygons up and down. Those polygons may exist in the digital mesh, or they may be added at render time, and we're going to cover how to set all of that up. So what we have here in the modeling viewport is geometry that I generated in Rhino using the shrink wrap tool, and you'll see that this starts as two objects. I have an object that I made manually by rotating and scaling boxes around, pinching their corners, and then using the shrink wrap tool to bind them all together. Then I used a little grasshopper to scatter some objects onto the original mesh. I then moved this scattered mesh down and shrink wrapped that, and then I shrink wrapped everything together, and then I used the quad remesh tool to have nice topology. So you can see the workflow here, a shrink wrapped object coming from scattered spheres in Grasshopper, this object which I scattered and then shrink wrapped. Then this is what you get by shrink wrapping these two objects together, and then using the quad remesh tool to get nice topology. And I should note that moving from this step to the quad remesh, it didn't work at first, and I needed to explode this mesh and get rid of a few small meshes that were disjointed from the original mesh in order for the quad remesh to work. So if you run into trouble, just be aware that that is an issue. And then I imported this geometry into Maya, and in fact, the first tutorial of this series shows how to import geometry correctly from Rhino to Maya, and watch that video if you need help. So now I have a sky dome light with, I believe, a physical sun and sky lighting this, and I've got a solid color as my background, and all of this is covered in earlier videos. You can see that I can select my sky dome light, so I'm just, well, I shouldn't be able to select it. Okay, great. No, I selected it here. Okay, so now we're going to get into texturing. So this is rendering now as a live render on the left here. If I move this around, you can see that this is updating. And we have a lot of what I would call geometry texture, geo-based texture on this object. So lots of ins and outs, and it looks like these spheres are being encrusted with something or perhaps dissolving. I'm sorry, these boxes, and yet we don't have any real, just a little bit of wrinkling on the surface, but we don't have any real texture. And we can see that we have a lot of polygons here, but everything is mostly smooth, and displacement, we'll use displacement to add texture to this. All right, I'm going to open the Hypershade, drag the window over. So here's Hypershade, so we can get this coming over. Let me pause the video. Oh, now it's here. All right. And let's go ahead and set this up. So I want to make a new material, and I will make by hitting the tab key, an AI standard surface. And I want to use, let me pause this for one moment. I'm going to use a preset. I'm going to use the plastic preset. And I'm going to turn off subsurface scattering only because, at least with my video card at this moment, this release, I cannot use the GPU rendering with subsurface scattering in the plastic material. And so I want to turn that off. And then I'll give the color just a slightly different color, make it a bit lighter. And now I want to assign this texture to my object. Let me go ahead and pull this over just one moment. Please, thanks, great. All right, and let me pull this over if I can. And I can now left So just to note, I'm taking the standard surface shading group and I'm dropping that onto the object. You can see that it turns blue, and now my object is blue. Okay, great. So now we have a live link between this shader and the object, and now I need to set up displacement. All right, so you'll see so we can have our standard surface shader here, and this is what sets up our materials, the bulk of our material properties. I can now also point out that we have a surface group. So this is a shading group. And shading groups, it can make it very easy to toggle between different surface shader options. So you could set up this surface, you could try a different one, or you could duplicate it, change its qualities, and plug it into the standard surface. And if the shading group is, and if the shading group is attached to the object, then you don't actually have to, you can switch the shader very easily just by plugging different things into the standard surface shading node here. All right, shading group. All right, so let's add, you'll see that the shading group is where displacement is located, and I'm going to hit tab. I have to actually add displacement to this, and I do this by making a displacement shader. And you'll see by default, the displacement shader comes with its own shading group. And I do not need this. I can just drag the displacement into the shading group that's attached to my surface shader. And if I look what's happening with the object, it's rendering, but nothing is changing. And that is because we need something to drive the displacement. So what's going to drive our displacement? We need a grayscale image to drive our displacement. And that image we could make in Substance Painter and link it up. We could paint it in Maya, or we could project it with an image map that we found. The way that I'm going to drive the displacement in this tutorial is with a noise. And so a noise is a way of getting patterned but somewhat random grayscale values. And there are many different types of noises, different patterns that are generated different ways. And by working with the settings, you can get many different types of patterning. Some of them can be more geometric. And the main type of noise patterns for Maya has its own noise patterns, and then Arnold has also a couple of nodes for generating noise patterns. So if you go to the help for Arnold and search for noise patterns, you'll find this great page, which gives us lots of recipes for making different kinds of noises. And it also points to how you can link the multiple Arnold noise shaders together. And those two noise shaders are AI noise and AI cell noise. And we'll be looking at least one of them in this tutorial. And let's do that now. All right, so our grayscale image is going to come from a noise. So to get that, I need to hit the tab key, AI noise, get our noise value. And I've paused the rendering up here, but now I'm going to unpause it so that I can see what's happening. And if I want to lock the shading viewport here onto this node, all I need to do is select this little blue button here. All right, out color. So we have this grayscale image. We need to link something into our displacement. You will notice by default that I cannot pull the out color into displacement. What I have to do instead is link the red channel to displacement. And that's how you get a link between any shader that has out color and you need more of a grayscale image. The easiest way is just to unroll this option and pull the red channel in. All right, now you can see if I lower the hypershade. Oops, I did not want to do that. Let me pause the video for a second. Okay, you'll see that once I lowered the hypershade window that we're now seeing displacement in this object. And before we do anything further, what I want to do is to remember to add additional geometry to this, to my mesh. So you can see that I have quite a lot of polygons, and I'm getting good displacement. However, this displacement doesn't have a lot of detail, and when we change the frequency of the noise, we'll add finer details, and we may not have enough polygons on this mesh to capture the detail. So what I could do is I could go to the modeling toolkit and smooth it or add divisions to it, but that's going to make my model quite heavy in the viewport. So what I'm going to do instead is tell Arnold to subdivide it further at render time. And I can do that in the attribute editor. I want to make sure that I'm on the mesh shape node. And if I come down to Arnold, then I can find subdivision. And you'll see that by default, this is set to none. And then I can change this to Catmull-Clark, which is the subdivision algorithm. And I'm going to leave this at 1 for now because it's already pretty dense, so I don't want to go overboard, especially while recording. But if we start to lose detail, we can raise this we can raise the iterations. Okay, so now let's start tweaking our frequency here. So we have the noise. We can also, what should we do first? We could either lower the displacement. Maybe let's look at the displacement itself. So the displacement is controlled here in the displacement shader, and this is on a per object basis. So unlike programs like Substance Painter, where you set a global value and then you have to work with the height of each mesh, in Maya, in Arnold, you use the displacement shader to control the height of the displacement on each object that has this shader. And the way I can do this is, so I should say it's on a per shader basis or shading group basis rather than a per object basis. Okay, the scale, I set the height here. And if I take this scale to 0, what we will see is that the displacement goes away. And if I change the scale to 0.5, then we get smaller wrinkles. And if I change the scale to, let's say, something like 3, we'll get something really much more wavy, and also probably the mesh starts to poke through itself. We can see the backside of the mesh as it turns inside out. So you have to be careful with the level of displacement. I'm going to go ahead and lower this to something like 0.5. And it would also be nice if there was something hanging out, which would just allow me to change that number without having to kind of dig down and find it here. And Maya lets us do that with a constant. So if I hit tab, I can type constant, and there's something called a float constant. And a float is simply just a number with multiple decimal points, and I can link that float constant into the displacement shader. I can do this in one of two ways. One, I can open the displacement, or I can select the displacement shader so that it's visible in attributes, and then I can come over and middle mouse button, click the float constant, and drag it over into the scale. And if that seems a little tricky, and I can set it that way, if that seems a little tricky, I can right click here, and down here there's an option to show all attributes on this node, so that I'm unrolling all of these attributes, and then I can see scale here, and I can click and connect scale that way. And then I can simply just I can click the buttons here, and it will hide many of the attributes that are not being used. So now I have this float constant, and I could call this, disp scale 1. So that's going to be this is going to be controlling the scale. So what we'll see is that now it's really large again because this default value is 1. So now I need to set it back to 0.5. And then it becomes less wrinkled. All right, now let's look at the noise value. So we have in the noise a lot of options. And the first thing that we would want to change is the scale. So right now this is set to a scale of 1, 1, 1. let's see if what happens if we try a value of 20. Copying and pasting that, 20, 20, 20. And now you can see my pattern is much finer, and that is going to result in a much finer pattern for my noise displacement. If I zoom in on this object and look at how the displacement is shaking out, I can see here that it's cool. It's a little bit furry, and maybe this is what we want, but I'd likely need to start dialing this down in most cases. And so what I want to do now is come back to the displacement shader and grab my displacement scale here. And let's try something like 0.1 and see if that gives us a better result. And we can see that now 0.1 is looking more like, this just looks more like a rough object, which I think is quite nice. Let's see if I can get this showing up a bit better. It's going to take a moment. Right, so now we have this working together. I'm sorry, I have this, I think the geometry and the displacement working together in a nice way. And we could then experiment with slightly different values, like perhaps 0.05. Oops, 0.05 would be even more subtle. And this comes in as just a nice kind of fine texture on the object. So, so that's pretty cool. I'm going to take this back to 0.1. And then I want to go through the steps again of adding an extra node to control a variable here. So we have the scale variables for X, Y, and Z, and I'm going to make another tab, constant, and grab float constant. I want to, this is set to 1, and if I change this to 20, I can now link this up here. Of course, I can't see the options, so I'm just going to show all attributes here. And down here we have scale, and I want to unfurl that, bring this down, and now I can link this up to X, Y, and Z. And maybe while I'm here, I will control, well, I'll just leave that for now. And now this gives us a way to quickly change. So if I open this noise value here, this gives me a place to quickly change that. So why can't, it's freezing for one moment. Because it was rendering this. So I'm going to go back to my noise value here, pin that in the window, and now I can change this to something like 5 and see what that does for my object. So now you can see I have a different kind of wrinkly pattern here. So this is all looking good. I can see that there's a warning message on my rendering here. So let's see what that's about. Okay, it says here that the padding is 10 times smaller than it should be. Let's change the displacement padding. And what it's recommending is a displacement padding of 0.38. It doesn't need to be this exact number, but as the displacement comes out, Maya might start to cut it off. And we want to make sure that or Arnold, we want to make sure that we see all of the displacement. So let's change that here in the, let's see, displacement shader itself. If we come to the Arnold spot here, we can change this to, it says 0.3. I'm just going to go ahead and change it to 1. It might complain, and hopefully not, but let's see now. I'm just going to stop and restart the rendering, and you can see now that that little error goes away. And I don't see any difference in the rendering, but this ensures that we are not going to get anything cut off. All right, so how do we add more control to the way that this is displacing? Right now we have a grayscale image, and this grayscale image has a full range of grays from, or maybe it's not going from absolute black to absolute white. At the same time, it is giving us a nice range of tones. But we can work with these tones by adding an Arnold node called range. So if we get the AI range, what this is going to do is allow us to change our grayscale. So we're going to bring the color, the full color information into our range node. And I'm going to go ahead and pin this. You'll see by default, there's no change. However, if I zoom in on that, if I click smooth step, for example, it adjusts the levels so that we have more contrast. So you can see the difference here. It's blurrier almost, and this sharpens it, so we get more contrast. And then this is going to change the way that our texture is being shown. So let me show the difference here. If I pull a little window here, now I can kind of zoom in on that, and maybe if I do that, so let me just re-render this again. Get rid of the window, re-render it, and let's put another window. I just want an area where I can see that contrast well. So it's rendering. Pause the video for 1 second. Oh, no, now it's rendered. All right, so let's grab this. Let's do this. We can see that we have pretty nice shadows here. If I go back to the hypershade and unclick this smooth step, let's see, do we see any difference? Hard to see. It's hard to see a difference in this spot. So but be aware that it is going to be important when we start clamping our image. So what do I mean by that? Our grayscale displacement. What do I mean by that? Well, in our range, we can, let's click smooth step on, and we can now start to constrain how these values are coming into our get output of the range node. So for example, if I just want things to go in and not pop out, I can take the input max and change this to 0.5. And you can see that this changes our image, and the result of that in our model here, let's see, should be a change. I don't think it's updating, so let me, right, because it would be important for me to actually link this up to our displacement, and that's why we weren't seeing the change before. Okay, so that makes sense. So with I want to change from the noise to now our new node here, so link that in. Again, I'm linking the red channel, and okay, now we see a change. So right, so now we get all of these things going in, and our object is quite patterned all over with these little indentations, which is nice. And if we go back and change the range further, we could make these indentations larger by taking the input min and making it closer to our input max. So 0.4. Now you can see that the image has a lot more contrast, and the shapes get bigger. And so we get bigger shapes also in our model here. All right, so let's go back and look at a few more things. So now we have this nice kind of texturing happening to our object. There's not a lot of detail. If you see this also we examine the texture that's applying the displacement, there aren't a lot of grays. It's mostly either black or white, or black or gray rather. And if we want to add more detail to this, we can go back to the original noise and look and add more octaves to this. So if we add some octaves, so I'm adding, let's say 2, you can see it starts to break 3. Right, so adding octaves begins to break up the edges of our noise, and then that's going to result in a more cracked like pattern here on our mesh. And this is where we might want to make bigger shapes, and to see that detail and to make the bigger shapes, we can come back to the noise frequency and change this to, and this is where the noise scale, this would be nice to actually name this noise scale 1. And let's take this number to a smaller value, so maybe something like 3, or even maybe 1. Let's try 1. Look at these bigger shapes. And what's that giving us? Okay, so we're getting these big shapes. It's kind of cool. Let's see if we can add more cracking to this by going to now the octaves here. So we can do, on the one hand, we can add more octaves to this, right? Okay, yeah, so by adding many more octaves to this, we should start to see a change here. Right, so now these edges are getting much more eroded. And this is where we might want to add more tessellation to our mesh to capture all that detail. And we could do that here with the attribute editor. And again, I want to, in the mesh shape node, find the Arnold tab and come to subdivision. And then we can change the iterations to 2. And let's see if that gives us any more detail here. Of course, then, and I think it does actually. We might also need to render out a higher resolution image to see all of that detail, but I don't want to get into that because I want to make sure that I have enough memory to record nicely. But I think we can see in here that we're getting quite a lot of nice detail in along those edges. We can do some more things in the noise node itself. So we've added octaves. We can also add distortion. So distortion is going to change quite dramatically how the noise is being distributed. We can also change the lacunarity. And this is also going to change the way that, right, we can go to something really simple. It's also changing how the noise is distributed. Let's see, we can, I think we basically want to keep all of this stuff the same. One thing I will note is that we only have one object, but you have object world or pref, and by default, this noise will be set to the object, and if we move this object around, the texture won't change. However, if we set this value to, let's see, if we set this mode, where did it go? The coordinate space to world. As we move it around, the noise will change because it's sampling a noise field that's existing in the coordinate space and the world space. And as we move the object through that noise field, it will change. And that can be nice if you want to use one object but have different patterns on it. You can set it to world, and then as you move it around, you'll get different texturing on that. So you can imagine some sort of brick or module that you move around, and that would change. All right, so this is looking pretty good, and so now maybe I'll just change the scale to 2, so we get a little bit more, and then I could continue to work with this lacunarity here, and the I could work with the amplitude. So what's the amplitude is? We could make a more even, something like that is giving us a lot of detail, changing the amplitude, and right, so we have quite a lot of cracked patterning here. And let's take this back to maybe 1.5 in the scale, and see what we get here. And this is all looking pretty interesting. All right, before we move on, let's look at one more. I would like to try adding noises together, and but before we do that, let's look at how the range is also influencing the way that the displacement happens. So by default, our output minimum for our image is 0, and our output max is 1. Also, if you have trouble reproducing the results I'm getting here, it could be because you don't have smooth step selected. That's a really important value for clamping things. So you can see if without smooth step clamped, I'm getting a really, really different kind of texturing here. So make sure that you click that value, and that's going to clamp things so that you get a more controlled texture and or a sharper division between the dark areas and the gray areas, the black areas and the blacker areas and the whiter areas. Now, what this means is that with respect to our original mesh, our texture is only is going up, and it's not insetting at all. And so what that means is, let me try this again. We can kind of see this here. We have our original surface, and then our texture is only going up from that surface. And if I wanted to maintain the original surface, I could set this to 0. And now it should go to smooth, and it does. And if I wanted the displacement to only move in, I could take this to say -0.5. And now when it textures, what we're seeing on these larger areas is the original surface of the image. And what we're seeing in these lower areas is something being inset. So I'm controlling where that happens. And I could kind of show you how that works just by using this, let's say that, and we can see here that this seems to be the raised part. And if I take our displacement momentarily to 0 here, and you can see that our raised parts are actually lie on the original surface, and everything else is being pushed down. So let me go ahead and change this back to let's see, 0.1 was our displacement. And now we have this. All right, so this is a nice texture, but let's say we wanted it to be more pockmarked or pitted. What we could do here is just to continue to, let's see if I can see this over here. Yeah, okay, so I've got these things, and do I have the, make sure that I turn that off so I can see the whole image. And let's just make a quick change here to the range. And let's take this down to say 0.1. And then if we put this at 0.1, this is nice. It's just nice to play with these values. Right, so we're getting a much more eroded object, slightly eroded, and this is where if we like the way this is going and we want this to be deeper, we could take our range node here and push it in more by taking our output minimum and making this like -1, for example. And now we're going to see that these fissures should be a lot deeper. So now this is much more eroded, and we could take this even further. Let's take -3. Let's see what this does. Pushing it in. Right, and you can see that this is now heavily eroded. So that's pretty cool. Now, what if we didn't want this to be? We liked the deeper moments, but we didn't really like how how widespread it was. We could clamp this with the range by taking our output max here and making it closer to our input min, sorry. We have our input min, our input max, and we could take our input max and lower that down to 0.2. And now you see we get this pitted surface here. And so we could start making this, like we could make this 0.2 and this 0.3. We could make them larger. Right, something like that. Take this down to 0.2. I'll put our output min to -2, so they're not quite as deep. And if we wanted more of them, we could probably go back to the to our AI noise, maybe the frequency of it. Let's take this to 0.5. What does this do? makes fewer of them. Take it to 5. And we should then get, right, now we get more of these things. Take it to point. Take this 4. And we can add this to, maybe make these things a little bit deeper, and we can do that here by, well, they're pretty deep already, and then we could look at if we wanted them to be a little bit bigger, we could take this to 0.3, our input max. That's a little, so what if we just do, so small values sometimes have a big change here, so if we take this to 2.5, we're getting a more even texture here. Okay, so this is looking pretty cool, and I want to do one more thing here, since just to add a little twist to this. I'm not going to add together displacement nodes in this video. Maybe I will do that in another video, but let's add an additional color to this object to make it more interesting. And I will also go ahead and just change my range shader one more time, because right now I'm not allowing any movement above the original surface, and maybe I'll allow a little bit of movement above the original surface. I don't know how much it's really going to change the object given how clamped things are, but we'll just add that in, and then we'll look at how we can add together some of these displacement nodes in a second video. But let's add some color to this. And one thing to note here is that because this, so I'll do a deeper dive on noises in another video. So one thing to recognize about these noises is that they're not, and you can actually see here in the noise, the coordinate space. I could set it to the UV, and the UV is the unwrapped map of the object. This object doesn't actually have any UVs. It came over from Rhino, and so it doesn't have any UVs. I could unroll it, but I don't want to do that for what I'm going to do next, which is add a color gradient to it. All right. But just so you know what I'm talking about, if I turn on the UV editor and pull this over and I select this object, you can see that nothing comes into this UV editor at the moment because I don't have any UVs on the object. Let me just put that away for a moment. So what I want to do is say, like, add a gradient to this object that's going from the top to the bottom. So I want the color to change from top to bottom. I can do that in the hypershade with something called a ramp shader. So ramp texture. And you can see that I have these, I can have multiple things here, multiple colors. Let me just maximize this. And let me go ahead and make this what I'm previewing here. And I'm going from black to gray here. I want to make this a color, so let's pick a color here, and let's pick just two like fairly dramatic colors. So now I'm going from pink to gray. Let's change this one to some sort of bluish green here, and now I should be going, let's see, it's not updating here, but I should be going from pink to blue. Maybe I'm just not seeing the way. We're doing a V ramp. We could also do a U ramp like this, and that should change things. Okay, so if I plug this into my standard surface shader here and plug this into my base color, let's see if we get a change here. All right, so we're seeing the pinkish color, but we're not seeing any blue. I can maybe run around this object and I'm not seeing any blue anywhere. I think any blue that I'm seeing is just coming from the lighting. And so this is not linked up to the object. And that's because we're using one of the texture space coordinates, U or V, whichever one it was, to project the texture, and I don't have any texture coordinates on this object. Because we're sampling a noise field that's in, let's say, that's being generated by the Arnold noise node, we don't actually need coordinate nodes for that. But to do our color shift, we do. So let's just say this is, even though it looks nothing like a cylinder, it's kind of long and linear. It has like more of this vertical orientation. So in my UV tab here, I can select a cylindrical UV mapping. Oh, I need to select this object, UV cylindrical. And is it giving us a mapping? Let's see here. So let's look at the UV editor. No. What's going on here? Let me pause the video and find out. All right, I figured out the issue. It was really dumb. Basically, when you select an object, you can be either in object mode or face mode, and sometimes Maya just switches on you for whatever reason. So I just had to make sure that I was in object mode here, so that when I selected my mesh, I was selecting the object and not individual faces. And now UV cylindrical, and you can see that it attaches this cylindrical mapping, and now my ramp shader knows where to go. And so I could either manipulate this mapping widget, and if it goes away, if you select the object, again going back into object mode, if I hit the T key, the Y key, it's not giving me that. I thought I could get that. I'm sure there's some way to get that little widget back, but we can also go ahead and look at our UV editor here. And it ain't pretty, but we do have this cylindrical mapping here, and we could start working with this if we wanted, but that's out of the scope of this video here. But we have this cylindrical mapping, and that allows us to use our, go back to Hypershade ramp shader here, and now you can see that our ramp shader, we've got a V ramp, so that's our V is going from top to bottom here. We could change this to a U ramp, and now you can see that it's going from side to side. The V-ramp was obviously more successful here. We could try these other ones, but I think the V-ramp is going to be the one that we're interested in. And then if we wanted to change how this is working, we could just like slide these things around. If we wanted to switch the positions all together, we could do that. So we could move that over there. Now we're going in the opposite direction, and we could, of course, add, let's like click on this ramp. I could add another color that it's blending, make it darker or something like that. I'm not sure what's going to be nice, but let's just see. Oh, that's not great. So let's make it a lighter color, something like this, light. That's something like a yellow, maybe. Something like that. There we go. So that looks happy. All right, so that's how you can link up the ramp shader. And in the next video, I'll just look at how we can blend noises together, and including, so we'll blend multiple noises together, and then we'll blend an AI cell noise and an AI noise together. Thanks for watching.